So here's our Chapter 9 review on quadratics. Going to go through some solving quadratic equations and graphing some quadratic functions, all right? So here we go. Let's get started with some quadratic equations. With these guys, we got some different methods, and the key is to find the right method. Here we just have an x squared, so we're going to add 5 to both sides. We don't have any x term, so we'll divide by 36. And we have x squared equals 536. So this is our square root method. We just need to square root both sides. When you square root a fraction, we square root the top and the bottom. So we have x equals, don't forget your plus or minus. Square root of the top is the square root of 5. Square root of the bottom is 6. Okay? See if I can draw a rectangle. There we go. Okay. Number 2 here. Now notice this one has just something squared here. So we got some parentheses squared. So we're going to get the 6 out of there, the 2 out of there, and then we're going to square root. Don't multiply this out. If you multiply it out, you'll just make a mess, okay? So let's add the 6 to both sides. The 6 that's outside, that is. So we're going to take this guy over here. And so we get 6. Then we're going to divide by 2. Okay, we don't want to square root yet. We got to get that square all by itself. And then we're going to square root this guy. And now we'll get the square root of 3. We want exact answers here. So x minus 6 equals plus or minus the square root of 3. And we're going to add 6 to both sides, add 6. And we'll like to write that typically as 6 plus or minus the square root of 3. And so we got 6 plus or minus the square root of 3 there. All right, this guy right here, we are going to have to multiply this whole thing out. So let's go ahead and do some distribution here. And we get 4x squared minus 8x. Distribute the negative 3x. We get negative 3x squared minus 3x. Multiplying that out there. All right, combine like terms. We've got the 4x squared minus 3x squared, that's 1x squared. Negative 8x, negative 3x, that's negative 11x. And let's add 18 to both sides, all right? Add 18 at the same time, we can do that. I think we can handle that. And now we need to look for two numbers that add to negative 11 and multiply to 18. And those numbers are x minus 9 and x minus 2, all right? And if you multiply that out, you'll get the this quadratic right here. Always be looking back. And then we got x minus 9 is 0 or x minus 2 is 0. You don't necessarily always need to write this out, but that's what's really going on. So x equals 9, or if we solve this one, x equals 2. 2 solutions there. Okay? All right. So again, on number 2, we didn't want to multiply that out because all we had was one parentheses. We can get rid of this stuff and square root. Here, we had 2 parentheses. They didn't match. We just needed to clean it up and get it into standard form. This one already is in standard form, so we'd like to factor. Are there 2 numbers that add to 2 and multiply to 3? I don't think so, because they're both positive there. So we're going to need the quadratic formula here, okay? Or we could complete the square if you wanted to. Hopefully we've got the quadratic formula memorized. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And you can sing the Pop Goes the Weasel song if you want there, and that helps you remember it there. All right, so we got, clean it up, negative 2 plus or minus. Underneath here we get 4, and this is going to be 12. So 4 minus 12 is negative 8. This is going to give us an imaginary solution. And so we have negative 2 plus or minus. The negative, that's going to give us an I under the radical here. And this is the square root of 4 times the square root of 2. And the square root of 4 times the square root of 2, we can go ahead and clean up the square root of 4 part. Square root of 8 is equal to this, okay? And the square root of 4 becomes 2 times the square root of 2, all right? And so, let's see here. This guy is going to be a 2 there. Okay. And now we notice we have a 2 in both terms. If you're going to divide here, you have to divide both ways. And does 2 go into both of these? It does. We can divide 2 this way, and leaving us with 1. 2 divided by 2 is 1. Okay. All right. So 2 goes into all 3 of these. All right. Really what's happening is we're factoring out. Or another way that helps people understand here is if they rewrite this as x equals -2, let's shrink this up, x equals -2 over 2 plus or minus, that's plus or minus 2 over 2 square root of 2i. All right, and then this cancels. This makes a -1. This is going to make a 1 times the square root of 2, and so this is -1 plus or minus the square root of 2i. In fact, that's what we want because this is in an imaginary number, and so we want this to be in a plus bi form. It's a complex number, all right? All right. Cruising along. This has an x and an x term, so we're going to want to get it in standard form. So let's move everything over to the right side. Subtract 2x and subtract 5. And we get 0 equals x squared minus 2x minus 5. Can we factor that? I don't think so. There's not two numbers that add to 2 and multiply to -5. So let's go to the quadratic formula. And so it's going to be something like this. Let's get some room here. So we have x equals -b. Watch out for that negative there. Plus or minus square root b squared minus 4ac all over 2a. All right, there you go. Then clean it up. So we have x equals +2 plus or minus the square root, and this business becomes +4. This is going to be a positive, because a negative times a negative is a positive. That's 20. So this whole thing's going to be 24 underneath the radical. All over 2. Let's see. There's a 4 in here. So this is 4 times 6. Square root of 4 times the square root of 6. Square root of 4 times the square root of 6 becomes 2 times the square root of 6. All over 2. And we can go ahead and divide both of these by 2. And it cancels out nicely here. We've got 1 plus or minus the square root of 6, or 1 square root of 6. Okay, remember that represents 2 answers. Okay, you can always go graph these on your calculator to check. So plug that in your calculator, and you'll get the decimal value for 1 plus square root of 6 and 1 minus the square root of 6. Okay, so number 6 here, we start by checking to see if this can be factored, and it cannot. So we have x equals -b plus or minus the square root b squared minus 4ac all over 2a. Okay, and so we end up with 4 plus or minus the square root of 16. What do we have here? 4 times 8 is 32, so this whole thing is -16 because it's going to be +16 minus 32. That's -16. And so we're going to get another imaginary solution here. We have 4 plus or minus 4i all over 2. And we want to divide both of these out. We want to break this into 2 fractions, especially because it's a imaginary or a complex number. Okay. So we end up with 2 plus or minus 2i. There's your complex solution. All right. Cruising along. All right, here's another one that needs to be cleaned up. So nothing can be done here. There's no common factors or anything, so it just needs to be put into standard form. So let's just do that real quickly. Distribute the 6. Distribute the negative 2x. That's a squared. All right. Let's clean up. Put the squares together here, and we have negative 12. Put the x's. Oh, the x's go away. That's kind of nice. And that equals 10. Since the x's went away there, let's now go to the square root method. Don't worry about bringing them all over to one side. Just divide by negative 12. And we end up with x squared equals 10 over 12 negative. Okay, or x squared equals negative 5/6 square root. All right, and it is a negative, so we're going to have an I in the end. Okay, we've got an I square root of 5 over the square root of 6. We don't want to leave that square root of 6 on the bottom, so let's rationalize the denominator here. And we end up with, so multiply by the square root of 6 on top and bottom. And we get I times the square root of 30 on top over 6. And, oops, don't forget the plus or minus when you take the square root. Almost did that. Easy to forget that. Okay? So there it is there. On to some completing the square. All right, we want to complete the square to get to simplify this into make it a perfect square. Okay? So we want to add half of the b value, in this case 12. So we got 12 divided by 2 squared. So 12 divided by 2 is 6 squared is 36. So we want to add 36, and then this whole thing here factors to make x plus 6 squared. Over here, we want to take negative 5, that's the b value, divided by 2 squared. Okay, so remember we want b over 2 squared. Okay, first we got to have an a value there of 1, so watch out for that. Well, this is 25/4. So if this was 25/4, then this whole thing would factor into x minus 5/2 squared. Okay, this will always be this thing inside here that we squared because it's the square root of 25/4. Okay, and it's negative here because it was negative in the b value. Now let's use completing the square to solve some equations. All right, so the key here is we want to make it equal to x squared plus bx. That's what we want to make it look like. And so it looks like this. And then we got to ask ourselves, what do we need to complete the square? And in this case, it's half of the 6 squared. Half of 6 squared is 9. Half of 6 is 3 squared. We get 9. And so this whole thing now can be factored into x plus 3 squared. And we get 10. And we want to square root. And we end up with x plus 3 equals plus or minus the square root of 10. Can't do anything with that stuff on the right there. So we subtract 3, and this is plus or minus the square root of 10 minus 3, which is the same as negative 3 plus or minus the square root of 10. Remember, this represents two solutions. This is negative 3 plus the square root of 10, and negative 3 minus the square root of 10. Next one, we're going to complete the square. The problem here is we already have the constants all by themselves. That's good. But the problem is this 2. So we've got to divide everything by 2. Okay? And when we do that, we get x squared plus 5x. That looks good now. Going to leave a little space because I want to complete the square. Need to figure out what I need to add to complete the square. And just like we did up above here, we want to... up here we had minus 5x. Well, down here we've got now plus 5x. But we have an a value of 1, and that's good. So let's go complete the square with that 5/2 just like we did above in that problem. And so the 5/2 squared is 25/4. So again, we have 5, the b value divided by 2 squared, which is 25/4. And you got what you do to one side, you got to do to the other. And so we end up, this guy's going to factor into x plus 5/2 squared. And this is going to be, if we make this is 3 over 1, which is 12 over 4, and that comes out to be 37/4. Practice your fraction addition, check that out. That should work just fine. Now we've got a squared here, so we can square root that thing away. That's good news. And we get x plus 5/2 equals plus or minus the square root of 37, and we get 2 on the bottom because it's the square root of 4. Let's subtract 5/2, subtract 5/2. Okay, and again, we kind of like to put that minus 5/2 first, so we have x equals negative 5/2 plus or minus the square root of 37 over 2. Okay. We could also write that as one fraction, negative 5 plus or minus square root of 37 over 2. Either answer is just fine. All right. So there's the first page. There's some solving equations. Let's go on to the next page and see what we can do with it. Now we're going to graph some quadratics here. So we have them in different forms, these equations. So the first one we have is in vertex form. Okay, so you want to be familiar with this vertex form. This is our y equals a times x minus h squared plus k. And so we can find our important features. We know our axis of symmetry is always going to be at x equals h. And remember, the sign here, the sign on this is opposite of what is in here. So let me back. Yeah, that's right. So what we're going to see here is we look over here. We got a positive 2 over here. So for this one here, we're going to have y equals negative 2. Okay? All right. That's our axis, and then our vertex is always going to be at h comma k. So our vertex is at negative 2, 4. And the a value is 3, negative 3. So it's going to open down, and it's going to be pretty steep. Okay? So there we go. That's what we know about it. So let's go find it. Let's get some numbers on our axes here. So we can label our axes, and then let's go ahead and find our points. We've got our vertex. First thing you need to find is the vertex, and that's at negative 2, 4. So that's going to be right here. And we know it's opening down, so we have an idea. We know this is going down this way. Normally, so you can do a couple things from here, okay? If you want, you can find some intercepts real quick. We need at least 2 other points. 5 is what we're going for. We'd like 5 points. Okay. So let's use the form. We know that normally with y equals x squared, we go right 1, and in this case, down 1. Okay. But we need to think about y equals negative 3x squared. What would that shape look like? Well, it would be down here, first of all, but it would go down 3 times as fast, okay? So we know it's going to open down. We're going to go right 1. 1 squared is 1, but we're going to go down 3 times as far as that. So instead of going down 1, we're going to go down 3. Okay, we're going to go down 1, 2, 3. We'll be right there. Okay, so we'll put a point there. We know our axis of symmetry is right through here. Goes through the vertex. It's a vertical line. And so across on the other side is a reflection point. All right, so Now, if we want to find our next points, because 5 points is best. 5 points will give us good shape. Let's go back to the vertex. We know if we go right 2, normally we go down when it's 2 squared. 2 squared is 4. That puts down here. But we're going to go down 3 times as far. All right? So 2 squared is 4, but 3 times 4 is 12. So let's go down 12. All right? So we have going right 2, and we're going to go down 12. Well, there's 4, 5, 6, 7, 8, 9, 10, 11, 12. Put us down here at -8. Okay? Now we got plenty of points to get a real nice graph. So let's graph it. Whoa, let's try that again. There we go. That's decent. That's not so decent. Okay. There we go. We'll slap some arrows on it. There's our graph. Okay. All right. Let's go on over to the next one. We'll go a little quicker here on this guy. So let's go to our next one over here. This one is not in standard form, so we're going to need to find the axis of symmetry here. So we have x equals -b over 2a. That's our axis of symmetry. So in this case, we have x equals -4 over 2 times 2, which is -1. So that is the x-coordinate of our axes here, of our vertex. So we know that the vertex is going to be somewhere on this -1 here. And so let's plug in -1. Let's find g of -1. Plug it in -1. We have 2 times -1 squared plus 4 times -1 plus, actually, -6. Okay. So figuring that out, we have 2 times 1, which is 2, and this will be -4 minus 6, and that's going to be 2 minus 10, -8. All right, so we got a vertex at -1, -8. And we're ready to graph it here. So we got our vertex at -1, -8. And that's going to put us right down here. Now we know that the a value is 2. So we got an a value of 2 here. So right now, since it's in standard form, a nice way to go here is just to find the y-intercept. If you want to plug in 0 for x, we get a y-intercept of -6. So there's a nice point for us right here. So we know it's going to cross through -6 here. I'm going to get a different color. So we got a point at -6. It's going to have a point on the other side of the axis of symmetry right over here. Okay. If we also think about the shape of this graph, the a value, y equals, the a value is 2. So let's think about y equals 2x squared. So thinking about the shape, the a value of 2, we know that normally we would go right 1 squared is 1. So we go 1 squared is 1, that'd be up here. But we're going to go up 2, so twice as far. So we're going to go right 1, up 2. That puts us there. Okay, same thing as we go to the left. Normally we go right 2, 2 squared is 4. That would put us right up here. But we're going to go twice as far. So 2 times 4 is 8. So we're going to from the vertex. It's always from the vertex. We're going to go up 8. That's going to put us right up here at our on the axis, okay? So there's that point, and there's another one over here, okay? So that's enough. Let's go ahead and draw in our parabola. Something about like that, all right? So let's go on down to the next one here. This guy is also in standard form. So let's go ahead and find the axis of symmetry again. Using x equals -b over 2a, we plug in, positive 8. Negative from the formula. Negative b is 8, and then 2 times a is 2 times -2. And that's going to give us -8 over -4, which is +2. So we got our axis of symmetry at +2. positive 2 over here. And now we'll plug that back in to find the y value of the vertex. And we get negative 2 times 2 squared plus 8 times 2 plus 1, and we'll figure that out. So that's going to give us a y value of 9. So we have a vertex of 2, 9. Let's find that vertex right on up here. And now we know the shape is negative 2, so we'll think about y equals negative 2x squared. That's our parent function. And so we know it's going to be going down because the a value is negative. And so it's going to go down twice as far here, twice as fast. So normally we go right 1 is 1 squared, but we're going to double that. So we're going to go from the vertex, right 1, down 2. And there's our point right here. And then we have our reflection on the other side of the axis. There it is. And then from the vertex, 2 squared is 4. Normally we go down 4 with our plain old x squared. Where's 4? 1, 4 there. Okay? But we're going to double that. So now we're going to go down twice as far as 4. So that's 8. 2 times 4 is 8. So from the vertex, go to the right. 2 squared is 4, but we're going to double it. Let's go down 8. That puts us right down here. And so we get 8. Oops. Let's try that again. And then we reflect it on the other side. There's our points. Let's get our curve. And there's our parabola. Now let's go on and find some problems, find some vertices here, okay? So we have x-intercepts and y-intercepts. All right, on these next couple problems, we're going to find some x and y-intercepts. Remember, x-intercepts happen when y is 0. And the y-intercepts happen when x is 0. Exact opposite, okay? So we'll write them as ordered pairs. So though that should make life easy. When x is 0, we have g of 0. And when you plug 0 in for all of these x's, these just wipe out. And you're left with negative 6. And that gives us a y-intercept of 0, negative 6. Now, to find the x-intercept, a little more challenging, so we're going to plug in 0 for y here. Let's get a little space to do that. So we have 0 equals, 0 equals 2x squared plus 4x minus 6. Okay, it's a quadratic equation. We're going to solve this using our methods. We can try factoring. We can try the quadratic formula. And so a good way to go here is divide everything by 2 here. And if we divide everything by 2, the whole side, we get 0 equals x squared plus 2x minus 3. Remember to divide everything on this side by 2, and that makes it nice and simple. Two numbers that add to 2 and multiply to 3 are 3 and 1, right? So we have 0 equals x plus 3 and x minus 1. So we get two answers, x equals negative 3 and x equals 1. Two solutions. So we have our x-intercepts are at negative 3, 0 and 1, 0. Two x-intercepts because this is a parabola, and our parabola can open up or down. In this case, it's opening up, and it's going to have one y-intercept and two x-intercepts. There we go. All right, off to this guy here. So we have our two intercepts. Let's find our y-intercept first. That's the easiest. So let's plug in 0 for x. And all those terms are going to wipe out here, and that gives us negative 13. So we have a y-intercept of, when x is 0, y is negative 13. All right. The x-intercept, well, that's when y is 0. So we have 0 equals negative 2x squared plus 9x minus 13. I don't think we can clean that up too much. We're just going to have to use the quadratic formula. And we can do that. X equals negative b plus or minus the square root. b squared minus 4ac all over 2a. All right, and we'll clean it up. And we get, what do we have here? We have 81. And we got minus, minus, minus. That's going to be 8 times 13 here. And 8 times 13 would give us 104. So it's going to be minus 104. Okay. So we have negative 9 plus or minus the square root of negative 23 all over negative 4. All right, right there, this tells us that there's no real solution to this. And when we're graphing, real solutions are the intercepts. So there's no real solution. Obviously, there's a imaginary solution, but we're graphing. We just want real solutions here. All right. So we say no x-intercept. It will not cross the axis. And we can kind of realize that because this has a vertex down at 13, way down on the x-axis, okay? So 0, negative 13 down here somewhere. And because it has a negative 2, then it's going to open down. And if you want to graph this on your calculator, you'll find out, yeah, yes, indeed, it doesn't have any x-intercepts. On to some application problems here. So we got some problems here regarding the height of a projectile. So problems that you can expect to do with these applications are to find the maximum height, to find out when the height is 0. Those are the two main situations. So we've got our problem, or equation, x of t, h of t actually, and we want to find out when it hits the ground. So when it hits the ground, the height is 0. So that's what we got to realize. Okay, we realize, hey, the height is 0 when it hits the ground. So we can use our function here, and we can plug in 0 for the height, for h. And we get this equation. And now we just got to solve this, all right? So let's divide everything. Let's clean it up. Yeah, good thing to do with equations, quadratic equations, is if you have a common factor, divide that out first, like 4 in this case. So 0 equals 3 plus 2t minus 4t squared. Now the numbers are a little smaller, a little easier to deal with. We're not going to be factoring that, I don't think. I guess it might work with the AC method, but I don't see that working. So let's go ahead and use the quadratic formula, t in this case, because it's not an x, equals negative b. Now be careful. This is our a, b, and c. If you want to rewrite it in standard form, go right ahead. That's great. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And so we have negative 2 plus or minus the square root of, we got 4, and this is going to be plus, because negative times negative is positive, 3 times 16. 3 times 16 is 48. All right, so this is going to be plus 48 all over negative 8. And that's going to be t equals negative 2 plus or minus square root of 24. Nope, 20. I can't add here. It is 52. I know there's a 2 in there somewhere. All over negative 8. All right? And so we go to our calculator, and we can evaluate this here. So we'll get a picture here. All right, so if we plug it in, we get, here's our plus, and we got a negative 0.65. Well, that doesn't want, we don't want a negative time. Remember, we're finding the time here. And so if we plug in the minus version, we get this. Now be careful, by the way. Make sure you got these parentheses when you type this in your calculator. Parentheses around the top, parentheses around the bottom, okay? So That's we got there. Okay, so that's a number 1.15. All right, that tells us that when it's 1.15, we are going to be hitting the ground, or the ball, whatever the projectile is going to be hitting the ground. All right, so let's jot this down. When t is 1.15 seconds. Don't forget your units. Okay, that's when it will hit the ground. Okay, next question is when it will be its maximum height. Now that is when it reaches its vertex. On this problem here, you got a hint. The hint says when it reaches the vertex. That will not probably be on a test, and you won't get that hint on a test. So we want to find its vertex. So we're going to take this equation here, and we're going to find its vertex from our original equation. So we want to find negative b over 2a, all right? Maybe let's go ahead and rewrite it. We could have done this a long time ago, I guess. 8t plus 12. All right, so negative b over 2a, let's find our vertex because it's in standard form. So t, not x, because there's no x in this equation here. All right, so t equals negative b over 2a, and a is negative 16. All right, and so this is negative 8 over negative 32. That's just going to be 1/4. All right, so we need to find out what the height will be at 1/4 seconds. So at that time, we're going to reach our peak. Okay, so we're going to need to find h of 1/4. So we can do that. So h of 1/4. You can go plug this whole thing into your calculator, but this actually works out pretty nice. So we have negative 16 times 1/16, because 1/4 squared is 1/16. This bit right here is just 8 divided by 2. So, or 8 divided by 4, sorry, that's going to be 2. And so this is just going to be negative 1 plus 2 plus 12, and that is 13. So that works out pretty nice here, all right? So when h is 1/4, then we have, when t is 1/4, then we have a height of 13, okay? So its max height is h equals 13, and when t equals 1/4 second, and this is in feet. All right, so there we go. Find our vertex when we're finding maximum or minimum, and when we're setting it equal to 0, then we need to find the 0, all right, the intercept. Let's go to the last few on the next page. 3 more applications here. Again, finding max and mins or finding zeros. That's the key here, okay? Number 19, we've got an equation. Number of pounds of milk recommended for a calf, X weeks old, is approximately found by this function. When a calf's milk consumption is the greatest, how much milk will it consume? So the key is when we find the highest, the least, the greatest, the smallest, we're looking for a vertex. So we need to find the vertex. So this just becomes a vertex problem. You can forget the milk business for the moment and just find the vertex. That happens at the axis of symmetry, x equals negative b over 2a. And so we have negative 1.3 over 2 times negative 0.2. All right. And so this is, since it's already a decimal, let's go find a decimal here. And this comes out to 3.25, all right? So now we just need to find P of 3.25, okay? So that is X. X is the weeks. We'll remind ourselves of that. And so now we need to find out, well, how much milk is that? So at P of 3.25, we'll find that. So we plug 3.25 in, and we can go to our calculator now. And in our calculator, we get to 8.3125, okay? So that would be the amount of milk, right? Number of pounds of milk, so 8.3125, all right? So we can say, write our conclusion at 3.25 weeks. Okay. The maximum milk consumption is 8.3125 gallons. Actually, it's not gallons, it's pounds. Okay. There we have it. On to the next one. So another max-min problem here. Publisher's trying to minimize the cost per book. Okay. So remember, maximum minimums, we're just finding the vertex. And we know that X represents the total number of books in thousands printed here. What's the minimum cost per book? So minimum, we want to find the vertex. And how many books should they print to get that maximum or minimum of the average cost? So first step, let's find out where that vertex is, the axis symmetry. X equals negative b over 2a, 0.015. And when we compute that, in your calculator, you're going to get a repeating number 2.33. So you can use that 2.33. The thing you got to be careful of is rounding too much because these are thousands of books, all right? So if you're going to use that, probably use 3 or 4 decimal places to plug it in, okay? It probably would be better to go ahead and get a fraction here. So I'll show you how that works. This is 0.07 all over 0.03 when you multiply that. If we multiply the top and bottom by 100, then this is just 7/3. That's an exact value, okay? 7/3 is exact, 2.33 is approximate. So for substituting here, it would be much more accurate to go ahead and use that 7/3 because I haven't lost anything. The moment you round off, you've lost some accuracy. So f of 7/3 is what we want to find here. So we have 0.015 times 7/3 squared minus 0.07 times 7/3 plus 26. And let's compute that. And we get about 25.918. So let's get our answer together here. So what does that mean? Well, x, let's remind ourselves what x is. X represents the total number of books in thousands. All right, so we have this many thousands, 2.33 thousands. And the minimum cost per book would be 25.91. That's in dollars. So we'll round that off to 92. All right, so let's jot down our answer here. So let's multiply this by 1,000, this decimal number now times 1,000. And we have at 2333, so moving that decimal over 2,333 after we multiply by 1,000 books. The minimum cost is $25.92 per book. All right. There we have it. Okay. One more. We've got a rectangular garden here. Another max-min problem, but we're going to have to get an equation for this. Okay, Ginger is fencing a rectangular garden using the side of a house. All right, so side of a house off one side of the rectangle. A picture is going to be really useful here. Here's the house. And we've got a garden that looks like this. Okay, and we know that it's got some width. We don't know what the width is. We want to find the maximum area is that would enclose the whole thing. Okay, with 40 yards of fencing. Only got 40 yards of fencing. So we can start with just a simple equation. We know the amount of fencing we have is 2W plus the L, and that's got to equal 40. Okay, the length and the width there. And so subtracting, we know the length is 40 minus 2W. So we now have length in terms of width. So this is 40 minus 2w. Okay, so those are the ones we want to use. So we got to find these in terms of the same variable, all right? And so we did that there. So we've got a width and 40 minus 2w, okay? So we know that the area, which is what we want to minimize here, maximize actually, sorry, area is length times width. But let's put those both in terms of width. So we have 40 minus 2w times w. Okay, and that's the area. So this is an equation we want to maximize. If we distribute this out, we can see this is 40w minus 2w squared. This is a quadratic equation, all right? If we want to put it in standard form, we have this. We don't really need to, but let's go ahead. Why not? Now we want to find the vertex, okay? So you got to keep in mind, this is a max problem. We're not looking for the zero. We need to find the maximum. So we know this. We know the max is at the vertex. All right? Let's find that vertex. So the vertex happens when x equals negative b over 2a, or actually w equals negative b. Negative b is 40 over 2a, which is negative 2. And that's going to be 40 divided by 4 there, which is 10. So when the width is 10, okay? And so the question is now, what would the length be? Well, we can find the length. We know the length here. We got this equation right here. Is 40 minus 2 times 10, which is 40 minus 20, which is 20, okay? And so if we have, remember we have two widths of 10 feet and two lengths of 20 feet, okay? And so we have an area of 10 by 20, which is 200 square feet, okay? So our final conclusion is this, is that the max area is 200 square feet when width is, let's see if I can write that in here. Width is, what do we say, 10 feet, and length equals 20 feet. And that gives us our 40 foot of fencing. Okay, hold on a second. Is this yards? It is yards. Okay, so we got to change all this back to yards. All right, now we're back to yards. So get those correct units. Okay, all right. There you have it. Remember, if we're looking for a max or min, you're looking for a vertex. If we're looking when something hits zero, well, we're looking for the zeros, okay, the intercepts. There you have it. Study hard, hang in there, and have fun.